So let's say this is the adjacency matrix that we're having. Now let's create the function def Dijkstra, and in this we will pass this adjacency matrix. Now here inside this function we will create a visited array to keep track of all the visited vertices. For that we will be needing the length of this adjacency matrix length, because the length of the visited matrix will be equal to the length of adjacency matrix. So initially all the cells will be having false as we haven't visited any cell yet or any vertex yet, and we will also be having a distance array to store the distances of all the vertices from the source. 0 for I in range V. So source to source distance will be 0, but all the other vertices, the distance of all the other vertices will be minus infinity, right? So here for I in range 1 to V, we are updating the distances of all the vertices other than 0. So distance I is equals to float infinity. Now the next thing that we need to do is to find out the minimum vertex, v minus 1. So now let's take a variable minimum vertex, and to get the minimum vertex we are going to call find minimum vertex method by passing distance array and the visited array. So let's create this function find minimum vertex, and let's pass distance array and the visited array. And initially let's take minimum vertex, the value of minimum vertex is, let's say, initially minus 1, and now for I in range, length of this distance array, and here we will update the minimum vertex equals to I. But what is the condition to update the minimum vertex? It must be minimum, right? So here we will check if it is the first element, then it will be, we won't check anything, it can be the first element as there is no other element for the comparison. So minimum vertex equals to minus 1, that means it is the first vertex. Or if the distance of at minimum vertex is greater than the distance I, if this is true and the vertex is not already visited, then we can update it as the minimum vertex. Visited I. So if this condition is true, then we can update the current vertex as the minimum vertex. Now let's return this minimum vertex from here. Minimum vertex, and now here in Dijkstra function we got the minimum vertex, and now we are going to do the stuff with this minimum vertex. And before that we're gonna mark this vertex as visited in the visited array. So visited min vertex set it to true. Now let's take a for loop for j in range V. Here we are going to find out the new distance first. So the condition is if the value of adjacency matrix minimum vertex j. If this is true, then the new distance is new distance is equals to the distance at minimum vertex plus the value at adjacency matrix min vertex j. Right? So now we're gonna check if this new distance is smaller than the previous distance or not. So here, if this new distance is smaller than the distance j, then we can update the distance j by this new distance. Distance j equals to the new distance. That's it. Now we can print the result for I in range V. Print the vertex and the distance from the source. Distance I. So now let's take this adjacency matrix here below this Feynman vertex and let's call Dijkstra function by passing this adjacency matrix. Now let's run this program. So these are the respective distances of the vertices from the source. And these are the minimum distances.